A couple of quick slides here to go through before I let you do that review sheet. Actually, I would have normally started the pH next, but it's Friday, and I didn't want to start it right before the weekend because that's stuff that's going to all fit together, and it's going to take more than one day to do. We are going to cover pH. We're going to do that starting Monday. A couple of days we'll spend on that. But so this is kind of some like leftover topics on acids and bases I wanted to talk about. First of all, amphoteric. Let's take a look at that word. A lot of times I like to do this. I like to talk about how you can usually figure out a definition by just looking at some prefixes. That's why a lot of those guys over there, when I taught biology, most of the things I had over on my word wall were prefixes or suffixes, right? And a lot of them in biology, you know. For example, osteo in front of something. What do you think of? Bones, yeah. Pro, okay, means usually what, before, all right? Homo and hetero, prefixes, right? And suffixes, itis. Whenever you hear itis at the end for a biology thing, what do you think of?
Disease.
Yeah, well, what particular kind? What's usually happening in an itis? Sinusitis, bronchitis? No. Inflammation. Okay, well, maybe that didn't work so well. But there are a lot of prefixes. We've seen just recently a word that looks like this. Amorphous. A meaning what in front of something? Not. And morph meaning, I know you're going to say it anyway, even though I just said it. What's morph mean? Shape, not change. So no shape. They have no true crystalline structure. See if you can't figure this guy out. What does amph? Where have you heard the word amph in front of something? So think of a word that starts with amph. What? Amphibian. Amphibian, right? What do you think of when you think of amphibians? Like frogs. Okay, what do you think of an amphibian? What does he do? He lives where? In both water and on the land, right? That's what amphoteric means. These guys can act either as an acid or a base depending on the circumstances. Okay, that's what amph means. Okay, so by the way, this is not just a little tangent. It's a neat little thing to show you how smart I am. All right, it's a skill. It's a study skill. Knowing prefixes and suffixes, the more you read, the more of these you realize, especially in science, are used everywhere. Okay, for example, we already talked about homo and hetero. What about hypo and per, right? Or hypotonic you had in biology. Now we had hypo, which meant one less oxygen than the chlorous acid. Okay, so you see these same things over and over again, and if the better you get at recognizing these prefixes and suffixes, the better you'll be at the SATs, where they're asking you in the vocab type sections to understand what these words mean, to know what these words mean, without memorizing them. Because a lot of times, I mean, you can't memorize every word, but if you put together the prefix and suffix, you usually figure it out. Like in this case, he's a guy that could be an acid or a base. Amphibian, kind of sounds like that. All right, for example, take a look at this. And by the way, you're going to get questions like this on this worksheet in a minute. Look what happens to HCl and H2O, okay, in this problem. What is H2O in this problem? From left to right, what is he? Everybody agrees a base? Because what is he doing from here to here? What's he doing? He's accepting an H. He's getting an H. Okay, so that makes him a base. Okay, now, don't go too far now. That makes him a base. But take a look at this. Now, by the way, in the same problem, the guy's not going to be both an acid and a base. It has to be depending on who he's around. If I were to add water to ammonia, I add him to a strong base this time. Here I was adding him in the first one, I was adding him to a strong acid. Here I'm adding him to a strong base. What happens to the water this time? Look what he does. What does he do? He gives up an H, which makes him an acid. He's an acid. So water is a great example of an amphoteric substance. He's not going to be both an acid and a base in the same problem, but he can be an acid or a base depending on the circumstances. He can accept an H like he does here to become H3O. Oh, and by the way, before I leave this, on this same worksheet, you're going to be asked about Bronsted versus Arrhenius. Okay? I can call, well, let's just see if we can do this correctly. Y'all agree he's the base. He's a Bronsted base for accepting an H. That means he must be a Bronsted acid, correct? And he is. Where's my Arrhenius acid? Is there an Arrhenius acid at all in this first one? Yeah, there is, because there are hydronium ions formed. And who's the Arrhenius acid? The HCl. The Arrhenius guy will never be the water, because the definition of Arrhenius is a guy who, when you add him to water, makes hydronium hydroxide acid. What would water be in this case? Well, he's an acid. He's a Bronsted acid. We all agree he lost an H to NH3. Is he also an Arrhenius acid? No, because I didn't make hydronium ions in this problem. I made hydroxide ions. What was NH3 in this problem? Bronsted base. Is he also an Arrhenius base? Yes. So well, why isn't water the Arrhenius base? For two reasons. One, if I call him an Arrhenius base while he's also a Bronsted acid, I just told you that can't happen. Can't be both an acid and a base at the same time. Secondly, it's the thing you add to water that is the Arrhenius or the Arrhenius acid or the Arrhenius base, not the water itself. Water's never the answer for an Arrhenius question. Okay, it's not the answer. All right, good enough. Now, the last thing, again, these are just kind of topics that didn't really fit particularly anywhere. I'm not going to be very long. I'm almost done. It's this last board here. But there are terms and things we've run across and will run across throughout acids and bases. Something called conjugate acid-base pairs. Okay? And the questions in the book, I have a little bit of homework questions, a few homework questions over here on that tonight, on conjugate acids and bases. We'll actually learn a lot more about this when we get to Chem 2. We actually don't really call them that as much, but it turns out that a lot of acid-base reactions go both ways. They don't just go one way. Okay? So, the stronger an acid in one direction, the weaker it's what's called its conjugate base. Conjugate base is simply what it becomes after he's lost a hydrogen. And by the way, vice versa for that as well. The stronger the base, the weaker its conjugate acid. Now, I'll try to explain that with an example because it's hard to, in words, it's very difficult to try to explain it. You have to see it in an example. And that's all I'll show you. Take a look. Look at this guy here. Copy him down and look what's going on. Must be spring. Birds are whistling in the trees. Okay. You all agree about who's the acid and who's the base in this problem, right? H2SO4 is becoming just HSO4. What did he do? He lost an H. And H3 is becoming an H4. He gained an H. The guy who gains an H and H3 is the base. The guy who lost one is an acid. Now, before you copy, I didn't mean all that to come at once, but yeah. So he's clearly the acid and the base. These guys are what are called the conjugate acid or base. Let's see if I can figure out which one they are. Well, in this case, you have to look at the reaction backwards. Okay? You have to look at it going that way. H2SO4, after he lost an H, became this guy. Okay, look at him going that way. What does that guy do going that way? He gains an H, doesn't he? Which makes him a what? Conjugate base. What is this guy doing going that way? He loses an H, which makes him a conjugate acid. Okay? So for every acid, if it's a reversible reaction, for every acid, you'll become a conjugate base. And for every base, will become a conjugate acid. And it makes complete sense what I set up here if you think about it. The stronger the acid, the weaker its conjugate base. If I have a very strong acid, it means he wanted to donate that H really well. which by definition means this guy's not going to want to get it back very much, right? So he would not be a very strong base. A base being somebody who wants to gain an H, you see? And vice versa. A strong base would be somebody who really wants to gain an H. Once he gets it, he's not going to want to give it back up, so he won't be a very good acid. So the stronger the acid, the weaker its conjugate base, and vice versa. Make sense? All right, good enough. All right, now that's it. There's a few questions on that over here. There's a few questions on everything on the chapter, on this worksheet you're going to be doing.